All right. Hello, and welcome back to the Thought Cloud podcast. Our goal of this conversation is to uncover a hidden gem that can inspire others along their academic journey. Our guest today is Kaeshav Chandrasekar. Kaeshav is a senior at UCLA studying electrical engineering. He is also the internal vice president of the Bruin Spacecraft Group, which was founded with the intent of providing a creative and supportive environment for space mission design and development at UCLA, where all students of all backgrounds can come together, united by a passion for space to do something amazing. They aim to give students the opportunity to acquire the skills necessary to become leaders in the space industry. So Kaeshav, we're excited to dig into your path. We're excited to see where this passion came for you, your involvement in Bruin Spacecraft and everything of that sort. So thank you for joining us today.
Yeah, well, thanks for having me. I'm super excited to talk to you.
Definitely. Well, let's get into it. So first of all, how did you decide to study at UCLA? How did that decision come to be?
So, in high school, I didn't really have like one college that I really wanted to go to. So I wasn't like particularly drawn to anything. But, after applying and after getting decisions, UCLA was among the top. And after going to visit a few schools, I really found that UCLA, like the campus, the weather, SoCal, it was just the place for me. So yeah, I got a quick tour of it. A lot of my friends are going as well. So yeah, it was a clear choice in my mind.
That's awesome. Where'd you grow up?
Yeah, well, I've grown up in SoCal too, so it's not too far away from home. So if something does happen, I can come back home easily.
Definitely.
Um, and I just can't get away from the SoCal weather. So
Oh my gosh, I don't blame you. I do not blame you. Well, what made you decide to study electrical engineering? Was that decision made prior to attending or prior to enrolling, or was that sort of along the way you figured it out? How did that unfold?
yeah, so I had a pretty strong inclination towards engineering since I'd say like end of middle school, early high school. So I got pretty lucky that I found what I liked early on uh, because I started doing robotics in middle school, and through that like competitive and kind of mentally challenging uh, environment, I really found what I liked, and that's like building things with my hands. And yeah, so I continued that throughout high school, and I joined some other engineering clubs in high school as well. That really kind of cemented uh, the fact that I wanted to do engineering. And looking at like the different kinds of engineering, I wasn't really like computer science per se, or mechanical engineering. I feel like electrical engineering was that field that stretched across so many different disciplines, and it was extremely applicable and was very like uh, it's still revolutionizing every day. Um, and I thought that was a really cool place to be. So yeah, I decided to do electrical engineering.
That's awesome. That's awesome. So you were pretty hands-on with circuits starting when, or were you kind of up until college not touching circuits?
Yeah, so I actually didn't get much electrical engineering experience in high school, I'd say. So I didn't really know what it was going in, other than maybe like my physics one AP class that I took, which is like basic circuits. So I didn't really know exactly what I was getting into, but I'd say I took my first circuits class like end of my first year. That's when I really got into electrical engineering.
Very cool. Very cool. So then this electrical engineering coupled with your passion for space, right? And how did you come to start to see that space was where you wanted to take these engineering efforts?
Yeah, so in high school, I was fortunate enough to have a CubeSat club. So a CubeSat is like a 10 centimeter by 10 centimeter by 10 centimeter cube-shaped satellite. So there were a few high schools in the area, and we were mentored by um, an industry professional. So he came and he like mentored us and helped us along the way designing a CubeSat. Um, so that was kind of my first introduction to the aerospace field. And joining that freshman year of high school, I was able to stick through that throughout my 4 years. And at the end of it, looking back, I was like, this is exactly what I want to do, is like send stuff to space. And yeah, luckily my senior year, um, in the beginning, like around November, we were able to launch two of our satellites within the span of a month, which was incredible to see. Like our work
Wow,
completed,
two in the
going up
span of a
to space.
month.
Yeah. So unfortunately, we did have one like sitting on the shelf for a while after we had completed it. So we were able to get two of them going at the same time, which is a really like surreal experience seeing, watching that rocket launch live. It's like, wow, something that I made is on that. That was just an irreplaceable feeling.
That is awesome. Oh my goodness. So that's when you fell in love. And then getting onto campus, did you know about Bruin Space?
No, actually, I didn't find Bruin Space until my second year, I'd say. So first year, I was primarily focused on classes and getting acclimated and joining IEEE, which is like the Electrical Engineering Society club on campus. And they have a lot of like good workshops and hands-on electrical engineering projects. So that was my first introduction to electrical engineering in the project sense. But I found Bruin Space my second year, um, and unfortunately, that's also when COVID hit. So it was first online, and I didn't get to experience the lab until my third year, which was last year.
Gotcha.
So yeah, I joined a project team on Bruin Space my second year, which was it's called Reach. It was the idea was building a 2U CubeSat, so two 1U, one 10 centimeter, 10 centimeter, 10 centimeter cube satellites on top of each other, that kind of form factor. Um, and to build like a modular payload design. So basically, we build all the supporting infrastructure, and then whoever wants can just insert their payload, have it communicate with, get power from the rest of the bus. So that was the original goal of it. Unfortunately, uh, our club did suffer a lot from COVID in terms of member engagement.
Mhm.
So our numbers dropped, and we had to close that project down, which is pretty unfortunate. But two sides of the coin. So I did get to join the other CubeSat project that was going on called Rapid my third year. So the Rapid is kind of it's kind of my meat and potatoes now. Basically, it's a 3U CubeSat, so not two, but three. So it's like 30 by 10 by 10 centimeter CubeSat. So, and the primary payload on this is the mission is to demonstrate a miniature ion thruster that was developed by a lab on campus, our plasma research lab. So basically, we're working really closely with the lab to integrate the payload into our CubeSat so we can operate it and collect data from space and prove it out that it works. So
Gotcha.
I got involved on the propulsion side for that. So I was first applying my electrical engineering experience to that in terms of like the electronics infrastructure to support the payload and like sending commands to it when to fire. Um, but also, I did become lead in my second quarter of my third year. So that allowed me to kind of look on both sides, not just the electronic side, but also the fluid flow side. So I had zero experience with that, and it kind of gave me a kind of a shock on trying to learn something from the ground up, how the fluid flow works for this thruster, and how to properly like build that kind of supporting mechanisms for that. So
Wow.
yeah,
Wow, wow, wow. So just really quick breakdown for those that maybe aren't as familiar with how these CubeSats work, but you've got your electronics, which work with the thruster, and then you've got your fluid flow. And the fluid flow does what exactly in relation to the rest of it?
yeah. So just a quick breakdown of the subsystems on the CubeSat. We have we have to get power from somewhere. So we have solar panels and we have a power distribution system. So we get the power stored in a battery and we can distribute that to whatever wants power. We also need to point in the right direction. So we have a control system that like allows us to orient ourselves in the right way. We also have a communication subsystem, which allows us to have like an antenna and radio system to send commands to the ground and send data to the ground and collect commands from the ground. So we can have like a two-way communication because otherwise it's space junk. Um, and then we have a command and data handling subsystem. So once we get these commands to the ground, we have to interpret them and send these commands to, let's say the command is to fire the thruster. This command has to be sent from the main computer to the propulsion subsystem.
Gotcha.
So that's the responsibility of that. And finally, the propulsion system. favorite, uh, is in charge of, providing the right electronic signals to the thruster to fire it, and providing the gas to actually, produce the thrust. So the electronic side interprets this command from the computer that's on the CubeSat. So let's say it says fire for 3 seconds at this thrust. Our boards will go, okay, we'll convert these to this command to this specific voltage values. And there's 5 different voltage values. And so it'll determine what values those have to be, and it'll give that to the thruster to fire. And then it'll also control how much fluid or how much gas goes into the thruster. So the thruster basically ionizes gas. Sorry, this is getting a little.
No, it's great. Yeah.
Uh, but the thruster, it basically goes to really high pressure and it loses an electron, so it gets ionized. So now it has a net charge, and that can be accelerated with an electric field. So if you have an electric field, the ion will be attracted to it, and it'll be expelled through the back of the thruster, causing thrust. Because the purpose of the fluid flow system is to provide the gas into the thruster in order to generate the thrust. So the thruster handles, shooting the gas out at very high speeds, but the gas needs to come from somewhere. So we have tanks on board the CubeSat that, when commanded, provide the gas. And so we have to build that infrastructure to understand the commands from the electronics, and then take those commands and convert that into gas flowing into the thruster.
Very cool. Wow. So your experience building these CubeSats and being a part of Bruin Space, what prompted you to take lead in the organization beyond just participating in projects? Why did you decide, okay, I want to be, vice president here? What was your thinking there?
Yeah, so it was actually quite a difficult decision for me because initially I was thinking of, clubs that I joined merely for technical experience, and I didn't really understand why people would do like administrative positions or like, different kinds of non-technical roles, because I just didn't see the point in that. But, the more that I got involved with the club, the more I realized that the potential for this club to help more and more students at UCLA. And I feel like I could do a good job at conveying how great it was for me to other people to join the club. And I feel like if I didn't step up, then I couldn't get my voice out on, why this club is so great, and why my experience, why other people should also have a similar experience to me in finding, what they really are passionate about and what they want to do for the rest of their lives. And that really motivated me to join like the admin board, so I can be involved in more than just the technical side. I can, influence the club and try to spread it to as many people as I possibly can.
Definitely. I love that answer. That's awesome. And I'm glad that you got that excitement about you and were able to share it. I think that's just, otherwise, what would you be doing with it? And that's, that's awesome. So after college now, what do you hope to do? This is your last year, correct?
Yeah. So I'm going into my final year, and I am thinking about graduate school now. So that's another thing that's like been on my mind quite recently, is applying for graduate school. So I'm considering both a master's and a PhD. I haven't completely decided yet, but yeah, that's definitely something that I want to do, is get more technical experience in, electrical engineering applications to aerospace, because that's where my passion really lies. And yeah, I think that graduate school is the next step.
I love that.
I'm a little scared, but also excited to learn more.
Totally. Do you know what kind of degree or research you'd be doing?
Yeah, so a lot of it was influenced by Bruin Space and the lab that I was a part of this last year. And it's electric propulsion. So stuff like these ion thrusters that, take gas input, and then at really high temperatures and pressures and ionize them, they lose an electron, and they get electrically charged, and then you can generate really, really efficient thrusters from that. And learning about that and the applications and actually working on systems that use that, was really like eye-opening for me because I'd never heard of this before this past year. And the applications of these kind of thrusters is very, very exciting for the future in terms of like deep space travel, robotics missions, because what the crux of the space problem is weight. And the heavier that something is that you want to send up to space, the more it costs. And minimizing that weight is the way to send up more things, for a longer time. And this way of like electric propulsion maximizes the efficiency that you can get out of these thrusters, which I think is extremely exciting for deep space travel, which really motivates me because I kind of want to go see what's out there
Totally.
in the future. So yeah, that's definitely what I look forward to studying about.
That's awesome. Awesome. Well, congratulations on making it this far, and all the hope to you going forward. That's super exciting. But we're going to close it out now with this rapid fire round. So I'll ask and you'll shoot back. But the first question for you is, what is the most stressful part of being a student day in and day out?
Oh gosh, well, I haven't been a student in a few months. I'd say the time management is definitely difficult because you're a student 24/7. It's not something like you can turn on or off. Trying to find the time to do your work the most efficiently, but also balance like being a person.
Totally. No, 100%. What would you say the most meaningful way for students to help each other is?
Ooh. Uh, Something that like I try to do is like through Bruin Spaces, kind of spread the word on things that have impacted me, and not just like clubs, but like sharing resources as well in classes too. That's especially beneficial for a lot of students because most of my friends I hang out with are in my classes too, and we're always really good about like sharing resources on that we find online, and that's a really good way to help fellow students.
Definitely. Definitely, definitely. What would you say your biggest hope is to accomplish during your time on Earth?
That's a deep one, but I think you can kind of guess. My goal is to basically expand the human consciousness into the universe and increase our understanding of who we are in this universe, as well as kind of increase our footprint, become interplanetary, intergalactic,
Heck
and maybe
yeah.
not in my lifetime, but that really like manifest destiny turned outward into the universe is really what gets me going.
That's awesome. That's super cool. And what is your top piece of advice for those who are early in their educational journey?
Keep an open mind to absolutely everything and try anything, try most things once. Not just like educationally, like in terms of classes or majors, but like clubs and like social activities too. You never really know who you are until you know who you don't want to be. So,
Cool. That's a really interesting perspective. Okay. Well, on that note, Kaeshav, where can people follow the work you're doing? Where can they learn more about you? Where can they keep up with your happenings?
yeah, well, on LinkedIn, I post relatively frequently. UCLA Bruin Space, at UCLA Bruin Space. On Instagram, is pretty active too. I feel like your work is also really great, and I really appreciate this opportunity to kind of tell my story about how I've grown as an engineer and as a person throughout my college and high school careers. Thank you.
Definitely. No, no, I'm glad you got to share your story. I think that's the whole point of this. So I appreciate it. And you've been an awesome guest. So thank you so much for coming on, and looking forward to chatting with you next.
Yeah, thank you so much, Oliver.